Okay, in this section we're going to talk about properties of trig functions. We're in section 6.3. More specifically, we're going to look at periodic functions, some identities, and then we'll talk about even and odd functions in this section. The book talks about domain and range of the trig functions. I was going to hold off on that though until later. So let's talk about periodic functions. If I have a 60-degree angle, or pi over 3 radian, same thing. I have a 30, 60, 90 right triangle, and again, of course, that's one of our common triangles, right? Opposite the 30 is 1, opposite the 60 is root 3, and opposite the 90 is 2. Sine of pi over 3, opposite over hypotenuse, that'd be root 3 over 2. Now, if I wanted to compute sine of pi over 3 plus 2 pi, that'd be the same as sine of 7 pi over 3. And if I'm at the pi over 3 radial line, and I go another 2 pi radians beyond that, so that I'm at 7 pi over 3, that's going to be the exact same radial line that we see here, or I'll be forming the exact same triangle. And so sine of 7 pi over 3 would also be root 3 over 2. Sine of pi over 3 plus 4 pi, well, that'd be the same as sine of 13 pi over 3. And basically, if I'm at this radial line here and I go 2 revolutions beyond, I'll be at the same spot producing the same triangle here, and I would get the same outcome, root 3 over 2. So basically, in increments of 2 pi radians, I'm going to have the same triangle being built, and therefore going to have the same resulting number, root 3 over 2, each time. Cosine of pi over 3, adjacent over hypotenuse, that'd be 1/2. And if I go another 2 pi radians beyond that, again, I'll be producing the same triangle there. Cosine of 7 pi over 3 would also be 1/2. Cosine of 13 pi over 3 would be 1/2 if I go 2 revolutions beyond that, etc. Okay, so here's a definition. It says a function f is called periodic if there exists a number p so that f of theta plus p is the same as f of theta for all theta. All 6 trig functions are periodic. The sine and cosine functions have a periodic factor of 2 pi radians, so we can see in this example here that if you move in increments of 2 pi around the center, you're going to be at the same angle that you were previously, or you'd be working with the same, 30, 60, 90 right triangle there. So the sine and cosine functions have a periodic factor of 2 pi radians. So does their reciprocals. The cosecant function and the secant function are periodic with a periodic factor of 2 pi radians also. K in this formula here is an integer. Okay. Also, K could be a negative. So, if K is a negative, I'm going increments of 2 pi radians around the center, but in the clockwise direction, right? Remember, a positive angle means that you're going counterclockwise. Negative angle means that you're going clockwise there. Okay, now the tangent and cotangent functions are also periodic, but the periodic factor is not 2 pi radians, it's pi radians. Here's an example. So tangent of 0 degrees is 0, right? Tangent of an angle is y over x. Tangent of 180 degrees, well, that'd be 0 over negative 1 is 0. 360 degrees would be the same axis here as the 0 degree axis, and so I get the same, 0 over 1 is 0. 540 degrees would be another 180 degrees past 360 degrees, and so you'd be working with this point again on the unit circle. So notice how we're getting the same output at increments of pi radians. Okay. Now this can be helpful to know for various calculations, okay, and also when we get to graphing in the next couple of sections, we'll be using the periodic factor there for the trig functions. In these next two examples, I want us to just find some values here. Cosine of 17 pi over 4. Well, 17 pi over 4 would be the same as pi over 4 plus 16 pi over 4. And 16 pi over 4 is the same as 4 pi. Now, I'd want to think of it in terms of pi over 4 plus 4 pi because basically if I'm at the pi over 4 axis and I make 2 revolutions beyond that, I'll be at the same pi over 4 axis. Okay, different angle, but the same radial line there, producing the same triangle, right? So in this problem, I would get the same answer as I would if I were to just compute cosine of pi over 4. Okay, I'm working with a 45, 45, 90 right triangle. The adjacent side in that is 1. The hypotenuse is root 2. So 1 over root 2 would be the value of cosine of pi over 4. It would also be the same number that you would get for cosine of 17 pi over 4. Here's another one, tangent of 300 degrees. Okay, well, in radian measure, 300 degrees is the same as 5 pi over 3 radians. And 5 pi over 3 is the same as 2 pi over 3 plus pi. And that's how I'd want to think of this, right? Because I said a moment ago that the tangent function has a periodic factor of pi radians. So the idea with these calculations is you want to think of how the fraction splits into two fractions, but where the second term there is either going to be pi or some increment of pi or 2 pi or some increment of 2 pi, depending on which trig function you're working with. So the tangent function is a periodic function where the periodic factor is pi, and so I would end up getting the same number as I would if I were to compute tangent of 2 pi over 3. Okay, now 2 pi over 3 is the same as 120 degrees, and so I'd be in quadrant 2 if I were to build that triangle. And I'll just quick do that here. So here's my circle, and I've got a 120 degree angle there. And here's so this is going to form a 60 degree angle there. Building my 30, 60, 90 right triangle. Opposite the 30 is 1, although that's going to be a negative 1 since you're going to the left of the center. Opposite the 60 is root 3, and then opposite the 90 is 2. Okay, so tangent of 2 pi over 3, tangent of an angle is opposite over adjacent. Root 3 over negative 1 is negative root 3. That'd be the answer. That'd be the same answer that I'd get for tangent of 300 degrees. Okay. The next thing says let P, which has coordinates x, y, be a point on the unit circle, so a circle of radius 1, that corresponds to an angle theta. Okay, if the angle happens to be in quadrant 1, sine theta, cosine theta, and tangent theta are all going to be positive numbers, since the adjacent side, the hypotenuse, the opposite side, and the hypotenuse are all going to be positive numbers. If the angle happens to be in quadrant 2, then the adjacent side is going to be a negative. That's not going to affect sine theta, though, since sine theta is opposite over hypotenuse. That's going to be a positive number. But cosine theta and tangent theta are going to be negative numbers, since the adjacent side would be a negative number. This last problem would be an example of that, right? The adjacent side is a negative number there. Okay, if I have an angle in quadrant 3, then both the adjacent and opposite sides are going to be negative, since you're going to the left of the center and then below the center. Of course, the hypotenuse is always positive, remember, because that's the radius of the circle. And tangent theta is going to be positive, since tangent theta is the same as opposite over adjacent, and negative over negative would be positive. Okay, sine theta and cosine theta are going to be negative, though, since the adjacent side and the opposite side are both negatives. The hypotenuse, again, is positive. Negative over positive is negative. If the angle happens to be in quadrant 4, cosine theta is going to be positive. The opposite side would be a negative, which is going to affect sine theta. And also tan theta is going to be a negative also. Okay. One way that you can maybe try to remember this is, so in the case of just these three functions here, sine theta, cosine theta, and tangent theta, all three are going to be positive. So I'll write an A. Only the sine function is positive if you're in quadrant 2. Only the tangent function is positive in quadrant 3, and only the cosine function is positive if you're in quadrant 4. Kind of a play on words here. All students take calculus. If you go around the center there counterclockwise, be kind of one way to remember this. So here's an example. I wanted to just name the quadrant that angle theta happens to be in. So sine theta and cosine theta are both negative. We can see that we're going to be in quadrant 3 here, since the opposite side and the adjacent side are negative. You're in quadrant 3. If cosine theta is positive and tangent theta is positive, well, tan theta is opposite over adjacent. That's going to be a positive, and cosine theta is also positive, so the adjacent side is positive, right? Looks like everything's positive here. Theta would be in quadrant 1. Okay, part C. Cosine theta is positive, and then cosine of theta is negative. Well, cosecant of theta, that'd be the reciprocal of sine theta. If cosecant theta is positive, then sine theta would also be positive. So sine theta being positive and cosine theta being negative, that puts us into quadrant 2. Theta is in quadrant 2. Okay, here's another example. Find the exact values of the remaining trig functions of theta. Okay, so in part A, they give us some information here. Sine of theta is 4/5 and cosine theta is -3/5. We're going to build a triangle, and we're going to compute the other 4 trig functions that were not given to us here. Okay, sine of theta is opposite over hypotenuse. The opposite side is 4. The hypotenuse is 5. Now, that should tell me that I'm going to be either in quadrant 1 or quadrant 2. Okay. Cosine of theta is negative, so I know I'm going to be in quadrant 2. Cosine theta is -3/5. Cosine theta is also adjacent over hypotenuse. The adjacent side is -3. The hypotenuse is 5, so I've got those sides labeled there. Of course, the adjacent side being a negative would be key for the rest of the calculations. Some students will mess this up and they'll have that be a +3. Don't do that. Okay, we're going to the left of the center. So now that we've got our triangle built, and by the way, we don't know this angle. This is a common triangle, but it's not a common angle. A 3, 4, 5 right triangle is probably the most common Pythagorean triple that you'd ever work with. What I mean by that is that, problems that involve the Pythagorean theorem, when they come up, some groups of 3 numbers seem to come up a lot. A 3, 4, 5 right triangle would be the most common, compared to any other group of 3. Like we see that more than any other. But we still don't know the angle, right? Now we don't care about the angle, right? We care about the trig functions of this angle. That's different. Okay, they're not asking us to identify theta or anything. Tangent theta, okay, opposite over adjacent. That'd be 4 over -3 or -4/3. Cosecant theta would be the reciprocal of sine theta. Sine theta is 4/5, so cosecant theta would be 5/4. Secant theta is the reciprocal of cosine theta. Cosine theta is -3/5, so secant theta would be -5/3. And then cotangent theta is the reciprocal of tangent theta. Tan theta is -4/3, so cotangent theta would be -3/4. And then here's part B, similar deal here. So sine theta is negative 2/3, and then theta is between pi and 3 pi over 2. Now, by them giving me this information about theta, they're essentially telling me that when I draw this triangle, the angle is going to be in quadrant 3 between pi and 3 pi over 2. Sine of theta is negative 2/3. Sine of theta is also opposite over hypotenuse. Now, I'd want to think of this as negative 2 over 3. Negative 2/3 can also be looked at as 2 divided by negative 3, right? But the hypotenuse will never be a negative, right? Because you're talking about the radius of the circle. So I'd want to think of this as negative 2 divided by 3, not 2 divided by negative 3. Negative 2 would be the opposite side. And the adjacent side is also going to be a negative here, since I'm going to the left of the center. If I just temporarily call that x and then use the Pythagorean theorem, the sum of the squares of the legs equal the square of the hypotenuse. If you were to solve for x, x would be plus or minus root 5. Now x has to be a negative since you're going to the left of the center. So negative root 5 would be the adjacent side here in this triangle. Again, this is not one of my common angles. That's okay. I've still got my triangle built here, and so I can compute the rest of these 5 trig functions. Cosine theta is adjacent over hypotenuse. The adjacent side is negative root 5. The hypotenuse is 3. Negative root 5 over 3 would be the answer there. Tan theta is opposite over adjacent. Negative 2 over negative root 5. Negative over negative is positive. So 2 over root 5. Of course, simplify, like you'd do any other math problem. And I mentioned, in the last video, you don't need to rationalize the denominator. I guess unless they're telling you to do that, don't bother doing that. Cosecant theta is the reciprocal of sine theta. So negative 3/2 will be the value there. Secant theta is the reciprocal of cosine theta. So 3 over negative root 5. Again, you don't need to rationalize the denominator. Cotangent theta is the reciprocal of tan theta. So root 5 over 2 would be the value of cotangent theta. Okay. I still have a bit more here. I'll stop right here in this video though.